Now we will go through how to understand the RTL specification document that we have provided and start coding using it. So the first thing you need to do is go through the whole document thoroughly. The overview gives a very high level overview of what you are going to do and how you are going to do it by running different tools. The next section is the start of the actual meat of the project, which is the RTL specifications. So please go through it carefully and thoroughly. The very important thing is the RTL block diagram. This is your starting point for your coding. So if you look at this example project, I have taken I2C as the example. This is the RTL, which is the I2C master. You see that it has some inputs and some outputs. The input names are defined together with the parameters that you need to define so that their width is defined properly and it is configurable when it is instantiated. So this will be the starting point. So based on this, you also need to make your functional driver, which will have the exact opposite inputs and outputs of the RTL. Of course, the clock and reset will be inputs to all components except for the clock and reset generators. All your components need to be encapsulated in a test bench which does not have any inputs or outputs. Now let us come to the port definition table. Here we have defined all the functionality of the signals that you have seen in this RTL block diagram. This will help you in making the internal signals and the internal blocks and other assignments that you will put inside your module. We have also provided read and write diagrams. These waveforms will help you in implementing the internal logic so that the register read and write is implemented properly. Next we move on to the register definitions. This is the functionality that the value of the registers will denote. Please go through each of these as they are very important in controlling the functioning of the module. Each bit is of importance and you can find which are the bit numbers and what is the functionality that they represent. In your code, this is what needs to be exactly done. So for example, in this control register, we see that bit 7 is the enable bit, and the functionality is this bit is used to enable the functionality of the module. So when you write a 1 into it, then only the module will work. So in your Verilog module, you need to implement the functionality such that all transfers go ahead only when bit 7 of the control register is 1. Otherwise, no transfers will take place. Similarly, the next bit, the bit 6, is the interrupt enable bit. So if the interrupt is disabled, then the interrupt line should not be asserted. Only if the interrupt is enabled, it should be asserted. So in your code, your interrupt line value should check whether this bit is 1, and then only it can be asserted. Similarly, you have to go through all the bits in all the registers. The I2C functioning block gives the functionality of the core I2C functions. This is what you need to study in detail to actually implement the Verilog code in your project. So this concludes our video on how to start off on the project. Once you start off, there will be a continuous process of evaluation of your code, and we will be continuing to give you feedback on how to proceed.